So for our last problem, notice I already factored this problem for you, so the factored form is exactly the same. Looking at each of these factors, I can see that x minus 4 divides out. Because x minus 4 divides out, that tells me I'm going to have a whole because I canceled out a factor. And it tells me that I have a new reduced form. So because I have a new reduced form, I'm going to use the new reduced form on all problems except the domain, which uses the original. Okay, so I set the denominator not equal to 0 on the original. So x cannot be positive 3, x cannot be negative 2, and x cannot be positive 4. So when I do my domain, I have negative infinity up until negative 2, union negative 2 to 3, union 3 to 4, union 4 to infinity. Okay, so because I have one factor that canceled, that is going to get me a whole. So I'm going to set the canceled factor equal to 0. So that's x minus 4 equals 0, so x equals 4. So I have a whole at 4 comma something. In order to find out that other something, I'm going to plug in 4 to the reduced factor. So I have 4 minus 1, 4 minus 3, and 4 plus 2 in the bottom, which gets me 3 over 1 times 6, which is 1/2. So I have a whole at 4 comma a half. Those factors that didn't cancel, that are still there, I'm going to set those equal to 0 to get the vertical asymptotes. That's x equals 3 and x equals negative 2. The two that didn't cancel become vertical asymptotes. The one that did becomes a whole. To get my horizontal asymptote, I'm going to use my chart. The chart that's going to compare the degree in the numerator to the degree in the denominator. So if I distributed out my reduced form, I would get x minus 1 on the top, and then I'd get x squared minus 1x minus 6. So the degree in the numerator is going to be 1. The degree in the denominator is going to be 2. So that because the denominator is larger, that chart tells me that my horizontal asymptote is y equals 0. The point crossing the horizontal asymptote is where I take my reduced function and set it equal to the horizontal asymptote. So my reduced function is x minus 1 over x squared minus x minus 6 equals my horizontal asymptote, which is 0. When I cross multiply, I'm just getting x minus 1 equals 0 times the whole denominator is still just 0. So I get x equals 1. So at 1 comma some value, I have a point crossing the horizontal asymptote. What is that y value? Well, I pull that y value straight from my horizontal asymptote. Since it is the point that is crossing the horizontal asymptote, I know it's going to have to be at the y equals 0. Next, to get the x-intercept, I'm just going to set my numerator equal to 0. Again, that's the reduced form. So my reduced numerator is x minus 1. If the numerator is equal to 0, then the whole equation is equal to 0 no matter what the bottom is. So I have 1 comma 0. The y-intercept is always 0 comma some value. To find that, I'm going to find f of 0, which I'm going to plug into the reduced form, which is x minus 1 in the numerator, x minus 3, and x, which is 0, plus 2. So that gets me negative 1 over negative 3 times 2, which is negative 1 over negative 6, which is positive 1/6. Okay, so let's go ahead and plot every piece of information that we already have. I know I have vertical asymptotes at 3 and negative 2. I know I've got a horizontal asymptote at y equals 0, or the x-axis. And I've got several points I can plot. At 4 comma a half, I know I have a hole. So I'm going to put a little hole right there. At 1 comma 0 I have a point, another 1 comma 0 because the point crossing the horizontal asymptote and the x-intercept happen to be the same. And then I have another point at 0 comma a sixth. So on the branch to the right of the vertical asymptote at 3, we know that because there's a hole up here, that means the rest of the branch has to get close to the vertical and horizontal asymptotes. So that branch is all done. But I need to understand more about the left side of the branch, so the part that is left of -2. So I'm going to pick something less than -2. I guess I'll pick -3. Use some space up here. So what I'm going to do is find f of -3 in the reduced function. So this gets me -4 in the numerator over -6 times -1, which is -4 in the numerator and +6 in the denominator. When I reduce, that's -2/3. So this one point at -3, -2/3, because the -2/3 is below the horizontal asymptote, I know that it has to stay below and get close to the asymptotes, and I know that branch. So the only branch that I don't know exactly what's going on here is in the middle. I do know that these two are going to be connected here, but does it go up and to the left, or up and to the right, or down and to the left and down and to the right? I'm not 100% sure. I'm fairly positive that since it doesn't cross the horizontal asymptote but just one place, that it's probably going to come up this way. But I don't know if this touches and comes back up, or does it pass through and go down. So I am going to find another point. I'll try 2 to find out what's going to happen there. So if I plug in f of 2 into my reduced form, I get 2 minus 1 over 2 minus 3 times 2 plus 2. That gets me +1 over -1 times 4, or 1 over -4. -1/4 is clearly below the horizontal asymptote, so the rest of my picture is going to have to get close to my vertical asymptote, and that is a pretty good picture. Notice it does cross the horizontal asymptote, it does have a hole, it does have 2 vertical asymptotes, which gives us an example of pretty much anything that you're going to come in contact with on a rational function. So this concludes our lesson on graphing rational functions.